Oh, there we go. All right, so we already have notes on all this stuff, but they're spread out amongst all kinds of like 7 or 8 pages. So now what we're going to do is we're going to put every single important piece of information from Unit 7 on this one sheet of paper so that we can refer back to it during our interim assessment and during our final at the end of this term, because our final at the end of this term will be about everything we've learned so far this year. Exponents, scientific notation, graphing, linear equations, all that stuff is going to be on the final that we take in 9 weeks. So I definitely hope you did not forget, but if you did forget some things, hey, I recorded every single lesson so you could always go back and review. But we're also going to review in class today. Let's talk about the first important thing here, which is distributing. It's the first step whenever we're solving a multi-step equation. So let's see how we're going to go about doing that. If we have example A, and example A is 2 times parentheses 3x minus 4 equals 4. As my pen dies. There we go, just like that. So we know that we need to distribute when we see what? What indicates distribution is needed? Brazon? Parentheses. Thank you, sir. We see we've got parentheses here. So we can imagine that both of those terms inside the parentheses, they're not going to go anywhere. They have to stay right there. But the 2 on the outside of our parentheses, that's the number we're going to multiply each of our inside terms by. So we multiply the 2 by the 3x and the 2 by the minus 4. And we get 2 times 3x and 2 times 4. Now, what sign is going to go in between those two terms? Anyone remember? Azalea? A minus sign. Where did you get that minus sign?
From the equation in the parentheses.
That's right. There was a minus sign in between them in our original equation, so we're going to bring that minus sign down. All right? If you keep that minus sign on the 4, you'll have to introduce a plus sign here, and it just gets really confusing. So stick with what we learned last year. Bring this minus sign right down in between the terms. And then we multiply these out. 2 times 3x gives us 6x, and 2 times 4 gives us 8. Bring down the minus, bring down the equals 4. Now we can go ahead and split our equation down the equal sign and do our inverse operations. I'll give you a minute to digest that real quick. Perfect. What is the first inverse operation that we need to do here? Azalea, what do we got to do first?
We gotta add 8 by both sides.
That's right. We're going to focus on the constant first. And we're going to do the inverse of minus 8, which is going to be plus 8. And just like we talked about in our warm-up, we got to add 8 to both sides, right? These 8's go away because negative 8 plus 8 is just 0, leaving us with 6x equals 12. Of course, our last step here is going to be dividing both sides by 6, leaving us with just x equals 2. 12 divided by 6 giving us 2, right? That right there is our distributive property. Again, it's the first thing you want to tackle anytime you see a kind of confusing looking equation problem to solve. Let's talk about the second concept here that's super, super important, and that is combining like terms. If you don't have room to the right of your distribution problem, you could just do this right underneath. All right, keep in mind, your notes don't have to look exactly like my notes format-wise. Content-wise, they should look the same. You should have the same problems and all that good stuff, but if you can't fit this off to the right, just write it out right under. That's fine. And let's take a look at example B with combining like terms here. Let's do 2x plus 4x plus 2 equals 8. Not too bad, hopefully. You guys all see that okay? Give me a thumbs up if you can see the board okay. Cool, okay. People in the back, I'll do thumbs up. That's what I need to see. So I don't see anywhere that we need to distribute or fraction bust. So we can go ahead and split our equal sign. What are the like terms that we need to combine here? Is it 2 and 8? Are those the like terms we're going to combine? Azalea?
2x plus 4x.
2x and 4x. Okay. So, the important thing about combining like terms, yes, 2 and 8 are technically like terms with each other. They're both constants. But they're on opposite sides of the equal sign. So what we're doing with those two terms isn't exactly combining like terms as we learned it. Combining like terms has to be on the same side. Azalea pointed out 2x and 4x are both on the left side of our equation. So if you remember, we're going to circle up our coefficients with the sign in between. And we're going to write that out in front. Now, if you can look at 2x plus 4x and in your head go, oh, that's just 6x, then you don't have to do this particular step. I'm just showing you exactly what we're doing here. 2 plus 4 gives us a new coefficient of 6 for our variable. So we're going to jump into our inverse operations now. We're going to subtract 2 from both sides. Get rid of those. And we got 6x equals 6. Someone help me out with my last step here. What's the last thing we need to do? I heard it over here. We're going to divide both sides by 6. All right, 6 over 6 reduces to just 1. So we get x equals 1. And again, this step here, these two steps, that was our inverse operations. Now, I'm missing something on these two problems, right? Does anyone think back real quick? What am I missing as a part of my answer for these two problems here? Any ideas? We're not missing units because it's not a word problem, so we don't need units. But we do need to identify how many solutions each of these equations has. We'll write this down in a little bit as part of these recap notes, but whenever we have a letter equals a number, like x equals 2, that means we have one solution. Same thing with example B. When we have letter equals number, that is one solution. Really is that simple. Letter equals number, one solution. Every single time. Yes, sir. Yep, go for it. Any questions so far on distributing and combining like terms? I know this isn't the most exciting thing to be talking about right now, but hopefully we remember most of this. It's not new information to us, which means it shouldn't be too hard once we get our worksheet. Let's go ahead and move on now, away from combining like terms, and let's talk about, ooh, my voice cracked really bad there. Let's talk about variables on both sides. Now, when we have variables on both sides, all we're really doing is inverse operations, except now we're also including our variable terms when we're adding and subtracting from both sides. So, let's go ahead and do example C. And we could say 3x plus 1 equals 2x plus 6. If we wanted to, we could go through and label each of these terms. I'll go ahead and split it up. We could label these terms. Is 3x a variable term or a constant term? 3x is a variable term. What about plus 1? Constant. 2x, is that variable or is that constant? Definitely variable. And then positive 6, that's going to be constant. So we can see here that once we do our inverse operations, we can only combine the C with the C and the V with the V, right? The variable terms are going to come together, and the constant terms are also going to come together. Let's start with the variable term. And let's think about this for a second. Do we want to bring 3x over to the right, or do we want to bring 2x over to the left? First part of that question is, does it matter? Does it matter which side we move which variable term to? No, definitely not, right? Now, it will make our lives a little bit easier if we bring 2x over to the left. Does anybody see why that might make our lives easier? To bring 2x to the left instead of bringing 3x to the right? Yeah, Hannah?
Then our variable won't be negative.
Exactly. If we bring 3x over to the right, thank you, Hannah, our variable is going to be negative, which means we're now adding in an additional step of dividing by that negative 1 at the end, right? If we do 2x minus 3x, we get negative x, okay? So we don't want to do that. Let's bring 2x over to the left. And if what I just explained confused you, just always bring your variable term over to the left, and we'll just leave it at that, okay? 2x's go away. 3x minus 2x gives us 1x. And then we can bring our constant term over to the right by subtracting 1. That gives us x, or 1x equals 5. So therefore we have x is equal to 5 as our solution. How many solutions does this equation have? Just one, right? We've got letter equals number. Yeah, Noah? Yep. Letter equals number, one solution. Variables on both sides is not too bad. Definitely not as difficult as distributing, in my opinion. All right, two more things we're going to talk about. Two more things. The first of those two is our favorite thing to do, which is fraction busting. Bless you, sir. Fraction busting. Luckily for us, we're not going to have to worry about this too much for the interim assessment, but we still want to talk about it so we don't forget. let's see. If we've got example D, let's do 1 over 6 x minus 2 over 3 equals 4. Can anyone tell me what's the first thing we need to identify here if we want to be able to fraction bust? Azalea, what's the first thing we got to identify? The lowest common denominator, right? The LCD. What is my LCD here going to be? Anyone got that? 6, right? How can we tell that our LCD here is going to be 6? Well, we see that we've got 6, 3, and an invisible denominator. What's the denominator over here? 1, right? We could put 4 over 1 just to cover all our bases here. We want each term in our equation to have a denominator. Once they all have a denominator, then we can figure out what the lowest common denominator would be for all those terms, right? So we see that 3 is a factor of 6, right? 3 goes into 6 evenly. So our LCD here is just going to be 6. Now, we're going to multiply each of our terms by some whole fraction, right? Whole fraction means same number on the top and the bottom. We're going to multiply each of these terms by whatever whole fraction is going to give us a 6 on the bottom. So what do we need to multiply this first term by? 1 over 1. We really don't have to do anything, but just to be consistent, I want to multiply that by 1 over 1. What about 2 over 3? If we want a 6 on the bottom, what are we going to have to multiply that 3 by? 2 over 2. A 2 over 2. And then what about 4 over 1? 6 over 6, right? Because our denominator is 1. The only number we can multiply that by to get 6 is, of course, going to be 6. Now we just multiply each of these fractions out. The first term does not change. Our second term, though, becomes 4 over 6. And our term on the right becomes 24 over 6. Now that we have all of our terms with the same denominator, what can we do with those 6's on the bottom? Azalea, what can we do with those 6's? Cross them out. Goodbye 6's. They all go away, leaving us with 1x minus 4, right? Just everything across the top equals 24. Now we can split our equation up, add 4 to both sides, giving us x equals 28. X equals 28. How many solutions does this equation have? Again, we only have one solution. The interim assessment we'll be taking on Friday is only 6 questions. It'll be multiple choice online. It will not be a graded assessment. It's just to get general statistics of student achievement. We'll just put it like that. But the interim assessment is very heavily focused on one, many, and no solution. So let's take a quick look at what each of those 3 outcomes might look like. We've talked a lot about one solution already. Right? One solution was like x equals 3. Letter equals number. Many solutions, which again is the shortened form of infinitely many solutions, is going to look something like 4 equals 4. We know that we have infinitely many solutions when we have a number that equals itself. Four equals 4, 0 equals 0. Even something like 2x equals 2x. If it's the exact same on the left and the right, you have infinitely many solutions. And finally, no solution looks a little something like this. Maybe 3 equals 2. So we know that an equation has no solution when we have a, basically, false statement. Does 3 equal 2, everybody? No, 3 does not equal 2. That is a false statement, so we would have no solution in that case. All right? And we're not going to do these together, but if you want to work out an example of these two by yourself, I'll give you a couple. Many solutions. Go ahead and try this. 2x plus 4 equals 2 times x plus 2. And for no solution, you could do 4x minus 3 equals 4x plus 5. Just two simple examples if you want to write those down and try them out on your own. Because a lot of times when you see these different solutions, right, you see 4 equals 4. And you're like, I don't even know how I would get something like that. Try out this example on your own and see. You will end up getting many solutions here, and you will end up getting no solution with the second example. I'm going to write examples to do on your own. Again, only if you want. You don't have to. I'm not going to check your notebook yet. Yeah. Again, if you want to see what those many and no solution type situations look like, you can go ahead and give those two example problems a shot.